Chemistry is present in our environment at several levels. Chemical products are used in large quantities for manufacturing, testing, transport, and decanting operations, as well as for storage. The use of these chemicals presents risks such as splashes and burns. The following training will deal with the chemical splash risk, the development of the chemical burn, as well as emergency first aid measures taken to prevent or decrease the chemical burn. The chemical burn is linked to the nature, the concentration and the type of use of the chemical product. Chemicals such as irritants and corrosives, while they are in contact with the skin and the eyes, can cause a chemical burn. The installation of preventive measures, as well as the use of personal protective equipment wearing, can reduce the risk of chemical burns by avoiding the contact between the chemical product and the skin or the eye.
Bonjour, Michel Protet. Je suis superviseur environnement, hygiène et sécurité au sein de l'entreprise Alcoa Fastening System. Dans le cadre de nos activités de fabrication, nous employons différents produits chimiques. Pour prévenir les risques éventuels associés à ces produits, nous avons mis en place un programme de prévention et d'intervention. Des formations et exercices pratiques sont ainsi organisés pour l'équipe de sécurité et pour tous les utilisateurs de ces produits. Ces formations s'appuient sur une meilleure connaissance du risque et traitement de la brûlure chimique et visent à mieux comprendre l'importance du port des équipements de protection individuelle. N'oubliez pas, les équipements de protection individuelle et des produits de premier secours sont à votre disposition. Utilisez-les, ils peuvent vous sauver la vie.
However, accidents are always possible. If an accident happens, then contact with the chemical presents a high risk of a chemical burn. A chemical burn is characterized by the total or partial destruction of cells, molecules, or the skin and eye structure. This destruction is caused by the penetration of the chemical through the tissues of the skin or the eye. This film shows the immediate destructive action on the eye cells of a rabbit of caustic soda, which is a strong base even in a low concentration. Following a chemical splash, the intervention time will be a decisive factor in influencing the outcome of any first aid measures. In the event of a chemical splash, the first step consists of an emergency washing. As a result of the emergency washing, the chemical product will be diluted and consequently less aggressive. In the case of acids and bases, the pH will be brought to an acceptable pH value. The mechanical effect of the washing can remove a large part of the chemical from the skin or the eye, approximately 80 to 90%. Solutions such as water or sodium chloride can wash the chemical products off the surface of the eye and the skin. However, as these solutions do not have any effect on the irritant or the corrosive potential of the chemical, it is necessary to start the washing within the first seconds following the accident. Diphoterine was created in order to overcome these limits. Diphoterine is an active and polyvalent solution, especially developed for the decontamination of chemical splashes. It is a solution that keeps the mechanical washing effect of water, but also has an absorption capacity which can stop the chemical aggressiveness. It has a double polyvalence. Diphoterine is effective on different chemical families: acids, bases, oxidizers and reducing agents, chelating agents and solvents, which are at the origin of the chemical burn. In the event of a chemical splash involving a base, caustic soda, ammonia, Diphoterine will be able to attract and fix the basic ion because of a specific acid site, encapsulate it and render it harmless. In the same way, in the case of an acid, Diphoterine will be able to attract the acid ion by a basic site and thus encapsulate it and render it harmless. Moreover, Diphoterine is a hypertonic solution that can prevent the penetration of the chemical in the tissue. We are going to carry out an experiment in order to demonstrate Diphoterine's action. The pH measurement will indicate the approximate acid or basic character of a solution. A solution is strongly acid when the pH is nearly 0 and strongly basic when the pH is around 14. The aim of this experiment is to bring the pH into the physiological area between 5.5 and 9. There will not be any risk of burns in this area. The chemical quantity used for this experiment is 1 milliliter, which represents double the quantity that can be present in the eyes following the chemical splash. First of all, we will take 1 milliliter of 1N caustic soda. The pH value is around 14, which means that it is strongly basic. We will simulate a washing with diphoterine, the objective being to bring the pH under 9. We will use 50 milliliters of diphoterine. The pH is quickly brought under 9. In order to show you the difference with other washing solutions, we will carry out the same experiment on caustic soda with tap water. In this case, we use a large quantity of water because water can only dilute the chemical product. This is consequently a passive washing, while the washing with diphoterine is active. We are now going to conduct a similar experiment, but this time with an acid, the hydrochloric acid. Its pH is located near 0. As with the caustic soda, we notice that the pH quickly reaches the physiological area using a low quantity of diphoterine. This experiment demonstrates the absorption capacity of diphoterine. How to use diphoterine? Diphoterine dispensers have been developed to be adaptable to the type of risk as well as the type of working place. Dispensers for the skin or the eye are available on fixed bases, mural station, or as portable items, and are therefore better able to meet the different risks. Diphoterine is always the same, no matter what kind of dispensers are being used. The sterile individual eye wash was created for people such as maintenance staff, who may frequently have to move from one area to another on site. This eye wash contains 50 milliliters of diphoterine, is to be used for an emergency washing within the first 10 seconds following the accident. Diphoterine dispensers have been developed to be adaptable to the type of risk as well as the type of working place. Dispensers for the skin or the eye are available on fixed bases, mural station, or as portable items. This eye wash contains 50 milliliters of diphoterine, is to be used for an emergency washing within the first 10 seconds following the accident. In the event of a chemical splash in the eye, twist the cap of the eye wash, open it, and start washing the contaminated eye. It is important not to apply too much pressure on the eye with the eye wash dispenser in order to allow the washing and the mechanical effect of the solution to take place. The wall-mounted station also contains a portable mini-spray for skin splashes. This mini-dap is an aerosol that contains 200 milliliters of diphoterine, which can be used for the decontamination of a face, an arm, or a front or rear torso. A micro-dap was developed for smaller splashes, such as on the hand or for smaller surfaces of the body. It contains 100 milliliters of diphoterine and was specifically designed to be used as portable equipment. The emergency washing has to be started no later than within the first minute following the accident. The portable shower unit has a 5-litre diphoterine capacity and is ideal for chemical storage, manufacturing and decanting areas. The solution is dispensed in the form of a micronized spray, which enables the full body to be washed. The emergency washing has to be started no later than within the first minute following the accident. For the LIS, the emergency washing has to be started no later than within the first 10 seconds following the accident. For the other dispensers of diphoterine, the emergency washing has to be started no later than within the first minute. Respecting this protocol is essential for optimal first aid measures. To conclude, there are a few key points. Diphoterine is an active and efficient solution on any irritant and corrosive chemical. However, diphoterine has a limited action on hydrofluoric acid and its derivatives. In this case, use hexafluorine. The entire contents have to be used for optimal efficacy. Do not delay a washing. Do not forget to seek medical advice. The specific danger of hydrofluoric acid. Hydrofluoric acid is used in the metallurgy, glass and electronic industries, as well as for specialist manufacturing processes such as photovoltaic cells. Hydrofluoric acid is not a common acid. It presents a double danger. It is corrosive at the surface of the tissues like any acid because of the action of H+ ions, and also toxic due to the chelating action of the fluorine ions on calcium, causing hypocalcemia. A small body surface contaminated with highly concentrated HF may lead to a lethal risk. The aim of the decontamination process is therefore to stop the acid action as well as the toxic action. Hexafluorine is a solution that was specifically developed in order to be able to achieve an efficient washing and also to avoid or limit the development of the burn caused by the hydrofluoric acid. It keeps the mechanical effect of the water, but also each molecule of hexafluorine has the capacity to encapsulate and neutralize 6 fluorine ions and 3 acid ions. Recent studies have shown its increased washing efficacy compared to water and calcium gluconate. Dispensers for the skin or the eye are available on fixed bases, mural station, or as portable items, and are therefore better able to meet the different risks. The portable shower unit has a 5-litre hexafluorine capacity and is ideal for storage, manufacturing and decanting areas. The solution is dispensed in the form of a micronized spray, which enables the total body to be washed. The emergency washing has to be started no later than within the first minute following the accident. The hexafluorine wall-mounted station for ocular washing was designed for production areas or laboratories and has to be accessible by everybody in areas where there is a chemical risk. It contains 2 hexafluorine bottles of 500 milliliters each for the washing of eyes. The emergency washing has to be started no later than within the first minute following the accident. To conclude, hexafluorine has to be used as soon as possible following the chemical splash, no later than within the first minute. It has to be used in accordance with the recommended protocol, and the entire contents have to be used for optimal efficacy. Do not delay a washing. Do not forget to seek medical advice.